Richard Piacentini, who is the co-founder and CEO of Sharkaroo. I hope you'll tell us how that changed.
JP will tell you.
Oh, okay, he's got a team with him, so
yes.
Whatever questions you have will be answered, I'm sure. To give us an overview of blockchain solutions, which is what his company specializes in, and also some specific industry examples of the applications, which will be helpful to simple people like myself. He calls himself a serial entrepreneur, and we have several in here that I'm aware of, so you'll be able to identify with him on that. But he also is, I quote, an ICO advisor. Anybody know what an ICO advisor is?
Thank you, Michael.
Okay, you'll find out from him. I'm not going to pick the suspense on that one. So let's all learn from Richard's 20 plus years of software development and leadership in many countries, not just Thailand. Welcome, Richard.
Thank you very much. Thanks a lot. Thanks for coming to the presentation. So I see that some of you already know about blockchain, so that's a good thing. And that's what we will speak about today. So quickly, this is Sharkaroo, Thailand. You have 3 on 4 actually. So you have JP that is here, you have Danny that is hiding behind him, and Crispin, our CTO, is in San Diego. So he cannot be here for now. But we are based in Thailand, and we are working on distributed ledger technologies, including blockchain. So this is what we will speak about today. And I guess everybody knows what is on the left. What is it? And what kind of technology Bitcoin is using. I think it's the most popular. You know it already. So Bitcoin is using a blockchain. And who know what is this one? No? So that will be interesting. So this is IOTA. IOTA is another distributed ledger technology, but interestingly, it's not based on a blockchain. It's a blockless blockchain, and we will have an example of this one. And the last one, have you heard about the last one? No? Thank you. So the last one is Stellar. It's a very popular network for exchanging cryptocurrency and assets. And this one also is another distributed ledger technology, and it uses a ledger chain. So the idea of this presentation is to let you see that blockchain is used for defining every kind of technology now, because blockchain has been invented before distributed ledger technology. So when people speak about blockchain, they are putting basically everything in it, and I will show you that there's different kind of technology that are not all based on blockchain, and probably in the future we will have more and more. So this is what we will speak about today. But first, this is where we are now. So I guess everybody has a bank account. Every time you are making a deposit on your bank account, the bank is taking care of writing everything and maintaining your account. You are not the one that are directly writing the balance and the deposit on your bank account. Do you see the screen? I'm sorry. Okay. So now with distributed ledger technology, it's the first form of ledger that can potentially eliminate third party. You don't need someone to centralize and control your operation. That's the point of the distributed ledger technology. All the participants are getting consensus and agreeing on decision, and they do that without a need of a third party. So we will see different kind of distributed ledger technologies. The most popular, I guess, is blockchain. So it's a kind of DLT. You have different one. Blockchain is the first one. It has been created for the Bitcoin, and it's actually the one that everybody knows. But you will see that we have other kind of technology like IOTA, Nano, or Hedera, and many, many others. But we will start with the Bitcoin blockchain. So Bitcoin has been established in 2008 by someone or some people that we don't know. That's the mystery of the Bitcoin history. We don't know who created it. It's called Satoshi Nakamoto, or they are called Satoshi Nakamoto, but there's no trace. We know that these people probably existed because there's an archive of emails on some cryptography mailing list, but at one point in 2011, Satoshi Nakamoto disappeared and left the code, and the developers now that are maintaining the Bitcoin are the Bitcoin core developers. And blockchain was invented initially for Bitcoin. It's the public transaction ledger of the blockchain. This is where everything is stored. Everything that happened on the network is stored on this blockchain. And Bitcoin is distributed. That means nobody is in control of Bitcoin. No company is in control of Bitcoin. And hello. And it's a complete distributed technology. So we will see how Bitcoin is working and what is a blockchain. So a blockchain, if you think about it, it's a data structure. And it has properties that are append only, meaning you cannot remove something from a blockchain. You can only add to the blockchain. And when you add something into the blockchain, it's immutable. You cannot change it anymore. And it's time-stamped. So this is basically the three properties that you need for a blockchain. An append-only data structure, immutable record, and time-stamped to know what happened and when. So this is how the Bitcoin blockchain is. And it goes through the time. Every time something happens, it's added into this, and you have numbers on the block. 1, 2, 3, 4. We are roughly at more than 500,000 blocks, if I remember well, on the Bitcoin blockchain this week, so there's a lot. And every time something happens, a new block is added to the chain. Like this. And it makes all these blocks linked together. So the question is, what do we have in this block? They look like boxes, so probably it's to store something. So we will see what is inside a block of a Bitcoin blockchain. So you will have basically three main things that are required inside a block. First, you have data. That's the point of the Bitcoin, storing data and let people agree on what is valid or invalid. Then you have a hash. So we will see in the next slides what a hash is. And the third thing that we have is the hash of the previous block. So this is basically the three main things that you will find into a Bitcoin block. So the first thing, the data, will be information about the transaction. Who is sending Bitcoin, the from address, the to address, the receiver and the sender, so, and the amount and the fees, because when you send some transaction to the Bitcoin network, you have to pay some fees. So this is basically what we find into a data block. There's a little bit of more thing, but that's the main data stored inside. Then we have a hash. You will see it if you look at some Bitcoin Chain Explorer. You will see these characters that are stored into each block. So you can think about a hash. It's like a fingerprint. A hash will identify uniquely a content of a block. It's like your fingerprint. We don't have two fingerprints that are the same, so everything based on the hash is unique, and the way it works is like this in Bitcoin. So you have the block data that we saw on the previous slide. You have information about the transaction. So these data are sent to a mathematical function. We will not enter in the detail of this, but you just have to know that it's a function that is applying transformation on data. And it's a one-side transformation. That means you can only go into one direction. When you get the final result, it's impossible to find what was the original content if you know only the hash. So the content of the block is sent to this function, and this function will generate a hash, the hash of block data. And what is very interesting in the hash function, they have a very interesting property. You can give any kind of data size to a hash function, the output will always be the same. I can send 100 megabytes of data to my hash function. My output in case of Bitcoin will always be 64 characters. Even if you use a blank space, you will get a hash of 64 characters. You have many different kind of algorithms, but this one is called SHA-256, and its property is to generate hashes of 64 characters. You have other like MD5 or SHA-2, or even you have a lot of different hashing algorithms. They all have the same property. You feed him some kind of data, you get an output that is unique and with always the same size. It's a very important property in case of a cryptographic function. So this hash is making the fingerprint of our block. This is what defines our block. That means if this hash is calculated when the block is created, and once it has been calculated, if you change anything inside the block, it can be a single character. You will have a complete different hash. The mathematical properties of the hash are there's no correlation between changing one character and expecting that another will change. No, it's a complete different output. Even if you change an uppercase to a lowercase later, you will have a complete different hash. It's impossible to recall what has been changed, and that's one of the properties. So if anything changes, the hash of the block will change, and then the original fingerprint that you had will not match anymore. It's not the same block. That means the hashes are used to ensure integrity of the data inside your block. If something changes in the block, the hash changed, so it's not the same block. It's a different block. And this is the third component that we have in a block. It also stores the hash of the previous block. So the previous block has exactly the same properties as our block here. It has a content. We just calculated a hash, and this hash is stored in the current block. That means here you have in green, this is the hash of our current block, and in blue is the hash that is stored, and it's the previous block. So when you want to calculate the hash of this block, and this is one of the most important properties of a blockchain, we take the hash of the previous block. It's a content. It's a string of 64 characters, so it can be used as a content. We take it, we combine it with the block data, and then you will send this content to the hash function. And the hash function will generate this hash. So you can see that you use some data from a previous block to generate the hash of the current block. So this is exactly what makes our chain of blocks. The blocks are linked to each other because they are referencing some data from the history, from the blocks that are previous in the chain. So this is the way to create an append-only data structure that is immutable because everything is referenced. So this is an example inside some block. So imagine that we have 3 blocks, and each block will have a link to the hash of the previous block. So you see that block number 3 is linking to block number 2, and block number 2 is linking to block number 1, and then we have a problem because there's no block before block number 1. Block number 1 is the first block in the chain. It has to happen one day when you start it. In the case of Bitcoin, it was in 2008. So we call it the Genesis block. And usually, the previous hash is hard-coded by the developer, and they put a message in it or whatever they want because it's useless. It's the first block in the history of your chain. So everything starts by this one, and it's called Genesis block. So you see that everything is linked together, and it goes back to the Genesis block. I mean, if you look at the Bitcoin blockchain today, you can go back, if you have time, and just go back to 500,000 something blocks and find the Genesis block, because everything is linked one by one since 2008. It's 10 years of data linked in a huge chain. So the problem with that is hashing is a good thing. It can guarantee integrity of your data. The problem is now we have very, very fast computer. This laptop alone can calculate 300,000 SHA-256 hashes by second. It's very fast. So you could, let's say that we want to tamper with a blockchain. So if we change the content of one block, remember the hash will change. So by doing this, we are invalidating the link. Here, this one is pointing to a hash that has changed because the content has changed. So something is wrong in our blockchain. But okay, let's say we can also rewrite this one because we have a very fast computer. So we recompute the hash of this block to match the one of the previous block. So then after you will have to rewrite all the chain. Everything that appears, the block following the content that you will tamper with has to be rewritten. But it's possible. It's even fast because with the computer that we have now, we could easily rewrite 10 years of Bitcoin history of hashes in a few hours. That would not be a problem. So to secure the Bitcoin network, we need something else. And that's what Satoshi Nakamoto invented. And he added a consensus mechanism that we call proof of work. That's the original consensus that has been invented in a blockchain network. It's not the most efficient, but still it's working. And what is proof of work doing? It's very counterintuitive when you think about it. Proof of work is an algorithm that has been conceived to slow down the block creation. That goes completely opposite of what we are trying to do in computer science since the beginning. We want faster computation. We want parallel computation, multi-threading. No, in Bitcoin, we want things to be slow and steady. And it's 10 minutes. The delay between each block on a Bitcoin blockchain is guaranteed to be 10 minutes. Every block will have some computation that takes 10 minutes. And this computation is a game. To solve the proof of work in a Bitcoin network, you are solving a cryptographic puzzle. That means you are using very, very fast computer. It's not even computer, it's mining rigs. And these mining rigs have to, we call it crack hashes. They have to try billions of hashes until they find one that is a good one. And this is steady to 10 minutes. You can have the fastest computer in the world, it will still take 10 minutes. That was the beauty of the invention of Satoshi Nakamoto. It guaranteed that there will be Bitcoin, the last Bitcoin will be mined sometime in 2140. I mean, we still have close to 120 years until we find the last Bitcoin. It has been calculated for this. And to guarantee this, because we have faster computer, if you know Moore's law, you know that we are basically doubling the CPU power of our computer every 18 months for the same cost. In Bitcoin, every 12 to 14 days, the difficulty of the network algorithm is adjusted. They want to guarantee that it's still 10 minutes. So every 12 to 14 days, all the hash power of the Bitcoin network is calculated, and the complexity of the cryptographic puzzle is adjusted to guarantee that it will still take 10 minutes. It's like this. And then when a new block is added, you still have to wait 10 minutes and get a new block into your chain. So proof of work is the most popular algorithm in blockchains today. That means you have it on Bitcoin, but you also have it on Ethereum, which is another technology. also based on proof of work in Ethereum 1.0. It will change in Ethereum 2.0, which is not here for now. The difference with Ethereum is it's faster than Bitcoin. That means basically you have 20 seconds to wait between the blocks, but still it's exactly the same technology. It's a proof of work. You have to find a solution to some cryptographic problem. And what makes the distributed part in distributed ledger technology, it's a network. So you have people that just connect to internet and they use a public peer-to-peer network, and no central authority is in charge of managing the Bitcoin blockchain. All these people on the network, they make the Bitcoin blockchain, and they are in charge of maintaining, validating the block. We call them miners in the Bitcoin terminology. So when a user is participating in consensus, it's a miner. So first, he has to download all the Bitcoin blockchain since Genesis block. As of today, it's 185 gigabytes of data. It's a lot of data. And the more Bitcoin transaction you have, the more the chain is growing. So maybe in 4 or 5 years, you will have 400 gigabytes of data. It's difficult to scale because of this. Why do they need that? They need to download the full chain to be able at any moment in time to verify that everything is in order on the blockchain. So they need to go back in history and check that everything, every signature, every transaction is correct. So each node miner is storing a full copy of the blockchain. And what happens when a new block is created? So let's say I'm sending a new transaction on the Bitcoin network. I'm sending 10 Bitcoin to Michael. No, not today. The new block will be sent to every node on the network. Everybody will receive this transaction and say, hey, there's a transaction for Michael. Here it is. So now, all the miners will have to check the block and verify that everything is done correctly. And once this is done, they just add the block to their own copy of the chain. Remember, everybody has a copy. So they add this block to their own copy of the blockchain. And then we say that all the miners participating in this round of consensus, they reached an agreement. They say, okay, this block and the transaction inside it are valid. So we agree on this, and then we can go to the next one. Okay. So let's say that we would like to tamper with a blockchain. What is needed if you really want, let's say you want to hack the Bitcoin network after the conference when you go back. So you have multiple things to do. The first thing is, you remember, you have hashes in the block. So okay, you need to rewrite all the hashes in your copy of the chain. That's the first thing to do. But that's not enough. You need also to recalculate the proof of work for every block. And remember, this takes 10 minutes. Whatever computer you have, it will take 10 minutes to recalculate for one block. If you want to recalculate 1,000 blocks, you just make the multiplication. It takes time. But that's not enough, because now you would have a copy of the blockchain, hashes are valid, proof of work is valid, but the problem is other people, they have a different copy. So you need also to take control of the peer-to-peer network. And you need to take control of at least 51% of the network. That's the only way to propagate your chain as the correct one. Otherwise, all miner will say, no, this is not the correct one. The longest chain is the one that is accepted by the Bitcoin network. So that's why you need to be in control of 51% of the power, and you can impose your own chain as the right one. So yes, it's complicated to tamper with a blockchain. It's extremely difficult, and it's also extremely costly. So the incentive of hacking the Bitcoin network is not really interesting for any attacker because it will probably cost more than what you will get in return. There's always a balance between incentive and return on investment. If you have a return on investment that is much below what you will have to spend, there's no point. That's why, to my knowledge, the Bitcoin network has never been hacked as of today. Does not mean that it will not happen, but for now it's extremely secure because of the combination of hashing, distributed technology, and the proof of work. When you put the three together, it really makes something extremely secure. So now the question is, why people are doing this? Because it's very expensive. You need to buy expensive mining rigs. You cannot mine Bitcoin with a computer like this. You will never find anything. So you need very expensive and dedicated hardware to mine Bitcoin. So the question is why people would do that. What is the incentive? The incentive is they want to be the first one to solve the cryptographic puzzle. So that means every time they receive the block, remember, they are trying to find the solution to the puzzle. Everybody at the same time is competing. It's a race. Everybody is racing against each other on the same block to find the solution. And once someone found it, he will send the block to the other, but this one is a lucky guy or the lucky girl. Because he found the solution to the cryptographic puzzle. You need to be the first one. It's a zero-sum game. That's very important to understand that because there's only one winner every 10 minutes. And the first one that found is rewarded with Bitcoin, which as of today is 12.5 Bitcoins, about 80,000 US dollar today, with a Bitcoin at 6,300. It's a lot of money. Plus all the transaction fees that are in the block are also added to the gift for the miner. So they get 12.5 Bitcoin plus all fees for the transaction inside the block. To give you an idea, you have between 2,300 to 2,500 transactions inside the block. It's another 80,000 or 60,000 dollars. So we could estimate that finding a Bitcoin block will basically get you $150,000, about 5 million baht, every 10 minutes for one block. So that's why people are really motivated for that. Because they make money. So the incentive of the Bitcoin network is money. You find a block, you get rewarded with Bitcoin, you can sell your Bitcoin, and you can have US dollar or Thai baht or whatever. And that's what makes the network work so well. People are incentivized. It should work because every time it works well, they get paid. And that's the best incentive you can find for dealing with this kind of network. So the problem with Bitcoin, at least from my point of view, is there's not a lot of use cases. The use cases for Bitcoin are basically you can store value. That means you buy Bitcoin, you wait for Bitcoin to get up, actually, or to get down. So that's why the store of value is not guaranteed. And you can resell it after. Or it can be used as a medium of exchange. But the problem is actually it's used as a medium of exchange of Bitcoin. That means people are exchanging Bitcoin. We don't have a lot of cases on the Bitcoin network. 2 pizza in 2010. Now it's the most expensive pizza in the world for 10,000 Bitcoin. A few Lambo in 2014, 2 Trilbo. One mansion in England for $17 million last year. So only, it's not actually, there's no adoption of the network for anything else than storing Bitcoins. So we would say that it's a financial network and people actually wait for finding a use case, and the biggest problem that we have is volatility. You don't want to buy a coffee at Starbucks today with Bitcoin just to realize tomorrow that your coffee cost you $150. Or Starbucks don't want to sell you a coffee today with Bitcoin to realize yesterday that they completely lose money. That's a big problem. Volatility is actually the biggest problem we have for the Bitcoin use case. And the network status is green. Bitcoin is extremely robust. It's in production since 2009. We have scalability issues. So we saw that in January when the market got crazy and the fees for Bitcoin was about $56 per cent something. And I remember myself sending a transaction of some interesting value of Bitcoin and looking at it during 6 days because it was stuck. You don't want that. It's really, really scary, you know, every time you are scanning the chain. So scalability is a problem, but there's a lot of things that are coming, like Lightning Network, and we hope that it will get faster, but still Bitcoin for me will always be a financial network. You cannot make application on the Bitcoin network. It's not made for that. It has not been conceived for that. And also, I don't think any company needs the Bitcoin network. The way it has been conceived by Satoshi Nakamoto or whoever is behind it, it's to be censorship resistant at a government level. Satoshi Nakamoto saw that an evil government would try to take control of the Bitcoin network and shut it down. So that's why he designed this network to be resistant to almost everything. Bitcoin is a war machine. I don't think enterprising needs that. You probably will not have an evil company that wants to tamper with strawberry on a blockchain. You don't need the same kind of security. That's why Bitcoin is really unique of its kind, and it's also the first one. But there's other technology. And something that is not blockchain, you remember IOTA, is another alternative is what we call a DAG. So DAG is a directed acyclic graph. So stay with me on this one. Directed because yes, you have a direction. Acyclic because you cannot go back. And a graph because it has edges and node. So this is a DAG. And this is not a DAG. You can see the difference. On not a DAG, you can go back. On a DAG, you can follow only one direction. Think about a family tree. A family tree is going only in one direction. You cannot go back, hopefully. So IOTA is based on a DAG, and it's a blockless blockchain. You don't have blocks in the IOTA tangle. That's how they call it. We like to have funny name in the tech industry, so this is a tangle. So it has been designed for IoT, Internet of Things. It has been designed first to execute fee-less transaction. I mean, you don't have to pay anything to send a transaction on the IOTA network. And also, it has to be extremely fast, and it has to scale. So it's a complete different architecture than a blockchain, and the Bitcoin, it's what we call blockchain 2.0 or blockchain 3.0, and this is how it works. On the IOTA network, each edge on the graph is representing a transaction, and they call that a site. That means that a site is storing everything exactly like the data in the Bitcoin block. It will store who is sending what to who, and everything that is related to the transaction is inside the node. So this is a site that you see with the pink dot. And all of these are creating the IOTA tangle. So each transaction needs to connect to at least two others. That's a very interesting part of IOTA design. It's a graph. So every time a new transaction has to be added to the network, it has to connect somehow to another one and to another one like this. Always at least two transactions. And they are all connected in this graph. And the graph, remember, is directed. That means everything that happens on the network is added from the right, and on the left you have all the older transactions. It's exactly like a blockchain when you start from a Genesis block, but here it's a graph, so that's a difference in the way the transactions are linked to each other, but it's exactly the same concept. So this, we call that the tips of the tangle. When you find a transaction without another transaction that has linked to it, that means this transaction is unconfirmed. It's here on the network, but it's not confirmed yet. So when a new transaction is sent, exactly like on the Bitcoin network and a new block, first, the IOTA algorithm will randomly select two tips on the tangles. That means two unconfirmed transactions that can be used to attach the new transaction. In case one transaction is invalid, the algorithm will rerun and find another one that can be used. So once we have our two tips of the tangle, the new transaction will link to it. And by doing that, the new transaction will validate the two other unconfirmed transactions. That's the beauty of the design of IOTA. It has been made to scale because every time you have a new transaction, you have two others that are validated. So on the paper, it scales. In production, it's different. So once our transaction has been added and has been validated the two previous tips, it becomes a new tip of the tangle. We have a new transaction, but our new transaction is not validated yet. Another transaction will have to be added, linked to this one and another one, and then you will have a confirmed transaction. So the question is, what's the incentive for IOTA? The incentive is basically getting the job done. You don't have any reward. There's no IOTA tokens that are given to you if you attach to a transaction, but it's made for Internet of Things and for organization. So they have an incentive because if they want to send their transactions, they need to validate two other ones. That getting the job done is one of the best incentives that you can think about. And IOTA has been conceived mainly for IoT trustless network. You don't want to have miner in an IoT network. If every time you send a transaction because your refrigerator needs to order milk and you wait for a miner, it will take time. So it has been made for this, so each device can be autonomous and do its job by itself. And it has been also really designed for smart cities. Because here you will have, we have an IoT expert, JP, or IoT expert. We will have a lot of transactions made by the smart cities. Problem with IOTA, actually, it's really work in progress. So I don't know any production or any application that really run in IOTA. It's in development, and it's an interesting technology, but I really consider it experimental. So the last one of our three contenders is Stellar Network. It's another kind of technology. First, it's open source. So that's something I really like because you can just go to GitHub, grab the code, look at it. Secondly, it's maintained by a foundation. It's a non-profit. Stellar Development Foundation has created it, and it's promoting that to provide really, really fast and cheap cross-border payment. It's very interesting. A lot of banks in Thailand are actually experimenting with Stellar too. So Stellar is using something else. It's not a blockchain, it's not a DAG, it's called a ledger chain. So it's basically like a bank account. So you have a Genesis ledger, like in any chain, and the first transaction on Stellar was in 2015. And a ledger will list everything that happened on a network in a given point in time. You will have all the accounts on the network. You will have all the trades on the decentralized exchange, because you have a decentralized exchange built on the Stellar protocol. And you will have all the data that you want to persist in the network, because you can also store data and cryptographically link it on the Stellar network. Basically, Stellar is using a SQL database below. So how does it work? It's the same. Each ledger is cryptographically linked to a unique previous ledger, like our blogs before. Every time something happens, you have a new ledger that is linked to the previous one. And Stellar is extremely fast. It's a 2 to 5 second consensus. So every 2 to 5 seconds, you have all these ledgers that are computed and linked to each other. And to be able to do that, it's a little bit like in the Bitcoin network. We have nodes. Stellar is a network, so you have computers that connect to this network. We call that a node. And a node on Stellar can be anything you want. You don't need a very expensive mining rig like for Bitcoin. You can do that with a laptop or with an old computer. Stellar is really easy to use. So each of the nodes, we call it a validator, they will run an instance of Stellar Core. Stellar Core is a software you install on your computer and you run it, and it's the backbone of the Stellar network. This is the software that is in charge of validating the transaction, getting the consensus, managing the network. It's open source, it's maintained by a foundation, and it's extremely efficient. The Stellar Core developers are extremely skilled. And the way it works is the validator agrees on a set of transactions every 2 to 5 seconds. That's their job. Here, no cryptographic puzzle to solve, no energy to use for nothing. It's just message and transaction. They agree on a set of transactions, and the protocol is called SCP. It's Stellar Consensus Protocol. It has been designed especially for Stellar by David Mazière, who is a Stanford professor, and it's extremely efficient. And the more validator on the network, the better, because more validator means faster consensus and the network will be stronger. So all these computers that are connected together, they make the Stellar network. And each of these computers is running Stellar Core, and Stellar Core is creating a peer-to-peer network. And then this validator agrees every 2 to 5 seconds on a specific set of transactions. When they agree, they go to the next one. So when you have a new set of transactions that is applied, a new ledger is created, and in Stellar terminology it's called the last closed ledger. That means the last operation that occurred on the network are stored in the last closed ledger. And you have a last closed ledger that is coming every 2 to 5 seconds. A new last closed ledger is created like this. And everything that happened before the last closed ledger is called the historical archive. So it's the memory of the network. So what's the incentive for a network like Stellar? Basically nothing. You don't get fees. But on Stellar, you have mostly organization. IBM use Stellar a lot. Deloitte, you have a lot of organization using Stellar. So their incentive is to make the network work because they need it for their own business and their own organization. So as validator on the network, they add more security, which is always good for their business. They can also submit transactions directly without using a third party, which is very interesting for an organization or a company. You don't want to rely on someone else to make your transaction. And they can also have a direct access to the history of the network. So very fast transaction. The fees are very low on Stellar. So with 25 cents, you could execute basically 100,000 transactions on the Stellar network. So it's very, very cheap. It's not free, but it's cheap. It's not free because the transaction fees have been added as a spam protection feature. It's not required, but it has been added to prevent spam. So what are the Stellar use cases? First one, fast, cheap cross-border payment. It's really made for the banking organization. And second one is tracking and tokenizing any asset on a network. You can take anything, tokenize it, issue it, and track it on the Stellar network and send it to anybody in the world in less than 2 to 5 seconds. So the status is very stable. It's in production since 2015. And for me, Stellar is actually the only technology that can have interesting use cases in production. It's already started in the supply chain with IBM and Maersk. in the financial payment with a lot of companies in Africa using Stellar. So these are some companies that are already on Stellar, IBM being the biggest one. And so in conclusion, this will end our presentation. We saw different technologies. So remember this, when you hear blockchain, blockchain doesn't mean anything unless you put it in context. You have the Bitcoin blockchain, you have other technologies. So when someone speaks to you about blockchain, ask him what kind of blockchain he's speaking about, and it will be much better for our industry. So thank you very much. Thank you very much.
Well, now's your chance.
Any question?
Yes.
Oh.
I had my hand up first.
Okay. You mentioned that, or you said that in the Bitcoin blockchain, every 12 to 14 days, the algorithm gets made more difficult.
Yes.
That sounds to me like there's a party acting there, or does that happen automatically in some way or other?
It's automatic.
It's automatic.
Yes. The algorithm in the Bitcoin core is checking the total hash power that you have on a network for the previous 2016 block, and is making an average, and then it can compute a difficulty for the cryptographic puzzle. And it's automatically applied every 12 to 14 days. And if you look at the Bitcoin history, it's very interesting because the Bitcoin price has been getting crazy since last year. But the hash power on the network is always growing. That's something that always bugs me. I don't really understand why, to be honest. But that means a lot of interests are mining Bitcoin, and this is not dependent on the price of the Bitcoin because the hashing power on the network never went down since the beginning. It's always getting up. That means more people are putting more power to mine Bitcoin, even if the price is going low. That's why.
Thank you.
Okay, his partner has questions. Please use the mic if you could.
Fantastic talk. I mean, I knew something about blockchain, but I've never heard of Stellar or IOTA, and my questions are about Stellar and IOTA.
Yes.
First, about IOTA, you said something about a transaction being invalid. How can an invalid transaction occur?
If you forge yourself a transaction with a fake signature, or you don't use the right private key to sign it, or you tamper with it, anything can make a transaction invalid.
But it would still be retained in the tangle?
No, because at one point it will be wiped out of the tangle if
Okay.
it stays too long. And the thing with IOTA is you don't know if something is valid until a new transaction comes and validates you. So they have some delay, but it's very, very experimental. I did not speak about the IOTA Consensus because it's still in development. It's a mix of how many transactions are already linking to you, meaning if you are an older transaction and you have a long chain of transactions linking to you, you're probably a right transaction. It's a little bit like the confirmation of Bitcoin. And there's also a combination of weight based on some trust on IoT devices. To be honest, it's very experimental and it can change, and it will probably change also.
Okay, and then about Stellar,
Yes.
did I understand you to say that there are no hashes involved? Or did I misunderstand?
No. There are hashes involved.
Okay,
There's no blocks, but the ledgers are linked to each other exactly like a block in a blockchain by a
Okay.
cryptographic hash. It's a different algorithm, and it's a different cryptographic layer. It's not SHA-256. It's called EC25519.
Okay, but it still has the immutability property.
Exactly the same.
And
The only difference is instead of storing the data in a data structure, they are stored in a simple PostgreSQL database. So it's very interesting. So you have records in a database, and you have columns in the table, and one column is called previous ledger hash, and another column is called ledger hash. It's extremely simple, extremely easy to integrate in enterprise. That's one of the technology we like the most, actually, yes.
And there's a single, at any point in time, there's a single ledger for the entire world.
Yes. Every 2 to 5 seconds, you have a last closed ledger, and then the world is moving. That's a very interesting way to define it. The entire world of Stellar is encapsulated in a ledger every 2 to 5 seconds. That's right.
Don't you think that eventually that's going to produce scalability issues?
that could, but the difference with Stellar, it's just message pacing. And we know how to scale databases since 20 years. We don't know how to scale a chain or a distributed network like Ethereum because it's new. Scaling databases to millions of transactions is something that we know how to do actually. So they may have scalability issues, but for now it's one of the fastest. It's about 1,000 transactions per second. And the more validator you are adding, the fastest the network is going. And I think IBM really realizes because they have, I think each IBM country has a validator on the network. You have IBM, they have 10 or 15 from the USA, from Australia. They are putting a lot of power on the network.
Thank you very much.
You're welcome.
Okay, I know Robert is going to have a question. But Robert, use the mic, please. Even though
Yeah, thanks, Richard. Robert.
Thank you.
I spoke to you at the beginning about, so hopefully you'll get a gist of it, I can say it very briefly, about my flood prevention system, which would be using, instead of having one big dam, having a multiple number of small retention reservoirs distributed through the river and tributary system. One of the lecturers here at a book launch mentioned the concept of using blockchain. Given what I've just described to you earlier, and would that be applicable to my design? Can you see a context for it, or one of the others perhaps?
So your idea was about dams, if I remember well. So you were speaking about dam.
Well, reservoirs actually,
yeah.
as
So
opposed to dams. Yeah.
Don't you think, based on the presentation, that's an interesting question, what kind of distributed ledger technology do you think you would naturally come to for your problem? Would it be a blockchain? Would it be a DAG? Would it be something else? What comes to you naturally if you think about it after the presentation?
Well, I hadn't heard of the other two before, but the ledger looks more simple.
I think the blockchain would not be a good use case for your project because you would have scalability and proof of work issues. So based on what you said to me, but it's very briefly, so I did not have time to really think about it, but an IoT technology is probably interesting because you would have a lot of information to send, or something like Stellar that can provide a very low fees, because otherwise this project would cost a lot in terms of fees. So I don't think that blockchain would be very adapted to your project. Maybe something more like IOTA, but it's quite unstable, or Stellar, or maybe there's really, really tons of different technology. I reference more than 1,500 different altcoins and chain actually, so there's a lot.
Yeah, thanks. I'll have a word with you later rather
You're
than
welcome.
disturbing everybody.
Sure.
Thank you very much.
We'll have time during networking just to answer more questions.
You said the Stellar doesn't use cryptographic puzzles, right? So
No, it's not a cryptographic puzzle.
yeah. So how easy is it to do the 51%?
You don't have a 51% attack on
Attack.
Stellar, you need a 66 because Stellar is based on what we call a FBFT. It's a Federated Byzantine Fault Tolerant. It's a little bit complicated. It has been designed in Stanford and it's a very advanced technology. It's basically based, I don't know if you're familiar with cryptographic voting, an algorithm called Praxis. No? So it's called a ballot voting. It's a system of votes. So the nodes are voting together to agree on a set of transactions. And they have a way, we call it an open membership. So usually the problem that you have with federated Byzantine system is you need a fixed list of validators. By example, you take Ripple. Ripple defines a list of nodes that are the validator on the network. If you want to add another one, you need to call Ripple and say, please, can you add my validator? So Stellar is, to my knowledge, the only federated Byzantine technology because it's an open membership. And the way it works is by quorum slices. So as a node, when you join the network, you will join a quorum. You will be a part of a slice of nodes. And this slice of nodes overlaps together. And then if someone decided to flood the network because they will add 10,000 nodes on it, you can just decide to not work with them. That's how Stellar is working. All the nodes are working together to reach a consensus slice. Once the quorum is reached, they vote and they go to the next one. It's very difficult to hack Stellar because of this, because at any point you can decide that if you are a Thai organization, you want to validate maybe with Thai validator because it's faster or whatever. You can always define who you are working with. And something interesting too, in Stellar, you cannot fork the chain. So you've heard about the Bitcoin fork. That means when people don't agree on Bitcoin, they fork. That means they take their copy of the chain and they go somewhere else. They call it Bitcoin Cash, Bitcoin Gold, Bitcoin Diamond, Bitcoin, we have all the name on it. Everybody has forked a Bitcoin blockchain. And you just have this duplication of history. That means you had one Bitcoin in this chain, another chain is created, and your Bitcoin is duplicated. We just invented the photocopy of money. So it's a big problem for a lot of people. Stellar is really based on safety over liveness. You cannot fork a Stellar chain. If the node cannot get the consensus, they just stop. This never happened, but they will stop and rerun the consensus. It's a few tenths of a second, but it's impossible to fork a ledger in Stellar. It has been really, really designed for this, and it's not the same with Bitcoin. Yes?
You mentioned about the tokenization of assets.
Yes.
in Stellar.
Yes.
Can you explain a little bit more on that?
Sure.
I can imagine if it's already, it's just something digital and it can be tokenized, but with physical asset, how does that work when you tokenize those kind of assets?
Very good question. So Stellar has a concept of anchors. An anchor is an institution, a company, an individual, anybody that has one leg on the network of Stellar and one leg in the physical world. So let's say I have a coconut plantation in Koh Samui. I don't, but let's imagine I have it. And JP is coming in holiday to Thailand, but before coming, he would like to have some coconut from my plantation. I could tokenize my coconut and say, okay, I will issue 1,000 coconut token on the Stellar network. It will take me 5 minutes to do it. It's very easy. And then I will send to JP one coconut token, and he can send me money by credit card or by whatever. And when he comes to Thailand and come to meet me in Koh Samui, he will be able to redeem his Stellar token, and I will give him one coconut. So you can tokenize basically everything you want. The only thing is the trust part.
Yes.
You need to trust me with my coconut and my token.
Right.
But it's exactly the same when you deposit your money into a bank. You trust them.
But because they are a bank, but this is just you.
But that's not very fair. But okay. Okay, I get it. If you go like this, okay. So if I was a coconut bank, you would trust me. But as it's just me, you say, no, I don't trust you. Okay. That's very,
we just
that's
met
right,
today.
okay. That's very interesting because this concept is implemented in Stellar. That means we have the concept of Trustlines. If JP wants, if I want to send one coconut token to JP, he need to approve me before. He need to say, yes, I trust you. And he can decide to trust me for a specific amount of coconut token. If he knows that I don't, if I issue 1 million of coconut token on the network and I have 3 coconut trees, probably he thinks something is wrong. So he can decide to trust me, but only for 10 coconut tokens. That means I will not be, even if I want to float him, if I want to airdrop him coconut token, I will not be able to send to him because he say, I want only 10. I not trust you for any more. So your question is very good because the problem here is not a technology problem, it's a trust problem.
Right.
How much do you trust the people you are working with? As anchor, you need to trust me to get your money, and when you come to Thailand, to get your coconuts. But it's exactly like this for any kind of asset. If you come and give me money and you want something in exchange, you need to trust me. And the problem is the entire cryptocurrency space. Everybody has the same problem. That's a very good question.
Do you want to give
Sorry. So trust is a really important aspect of any kind of either financial or physical transaction,
Definitely.
right? It's a really good question.
Yes.
But do you want to give maybe a couple of old-fashioned examples where tokenization was already taking place, but maybe we didn't call it tokenization and there was still trust? Maybe something like
Bonds.
Disneyland?
When you buy your ticket
When you
before.
buy your ticket before, you get this
Yeah, but
dollars
it's
or whatever.
sneaky. You trust
I
me
understand
because
that.
it's sneaky.
But the other thing is,
For me, no.
but how about a traveler's check?
That's a good point.
So I give
this
a-
was very popular maybe 20 years ago.
But I give
think
dollars
some
to...
people are too young for
yeah,
this now.
but it's the same thing, though.
But
right?
that's
I give
exactly the
dollars
same
to
thing.
American Express, and I get a piece of paper
Yes.
on it that says that I have dollars. And then I go to
Right.
Italy and I lose that.
Very good point. Who remembers traveler's check? That's exactly
But
what
that's just
Michael-
tokenization of cash,
Okay,
right?
everybody over 50 like me remember, but nobody else. So,
The only point is you're just digitizing
Yes.
something that's been physical for years. And we do that in every kind of aspect of our lives today.
but we trust Thomas Cook. Maybe we should not.
Fair enough.
So what Michael is explaining is exactly that. We already have this before. It was not digital. It was a check. Would be the same. Or a traveler check. Yes, and the check, you had the centralized part. But a traveler check is a perfect example. If you want to travel to a country and not take money with you, you would buy this in your country, and then when you arrive, you will be able to redeem it against. It's more. So the old way to do tokenization. That's right. Very good example. Thank you. So that's the same thing. You need to trust Thomas Cook somehow. Yes.
Yeah, is that not just like buying a ticket for a bus or a train then? I mean, you're buying that coupon and you're passing it on.
The same. Yes. Yeah, exactly. Everything that you buy and that will entitle you to a future service or agreement has exactly the same problem. But you have also a lot of copy. You can buy a copy of, people sell you fake ticket for concert or whatever. They're just duplicating this. So a lot of things can be tokenized, and basically everything can be tokenized. That does not mean it has to be. A lot of things probably are much better like this, and you don't want to add the tokenization.
So what's wrong with money then?
What?
What's wrong with money then?
What's wrong with money?
I mean, that's a token as well. That's based on a gold
You have
thing. It's
different kind of money, because we will not go back to the history of money, but we started with barter, and after with metal, and after with gold, and it was very heavy to carry. And barter is not working, because if I want to barter something and you don't have it, I cannot use it. So then we used notes, and then we used electronic money, because a credit card is just electronic money. You have exactly the same problem with trusting the bank now. Let's say that you put 1 million baht on your bank account. You don't have 1 million baht. The bank is using this as a fractional reserve. They keep 10%, they put 90% on the market. If the bank crashed, it happened already in 2008, in 1998. What happened? But you say, no, I trust them because they are banks. But that does not mean that this will not happen.
But the difference with money as well, sorry to interrupt you, is that it's not on a distributed ledger, which means that there's only one copy of it somewhere, and that one copy is owned by one institution, and that's where you're screwed. What a distributed ledger technology allows you to do, particularly if it's consensus-based, is it means that there has to be mass agreement. In other words, you can walk into your bank today and say, I want to take out $755,475, and they can just say, you don't have that money. And you're like, well, I had it yesterday. Which authority do you go to fix that? But if it's on a distributed ledger technology, 51% of all, if it's on the Bitcoin network or on the blockchain network, some consensus has to take place to make sure that that's unchangeable. That's the difference between money. And the other thing too, if you go back to the example of a traveler's check, is that if you have $100 in your pocket, first of all, no one knows you have it. Nobody. And if you lose it or it gets burned, you have no recourse. But if you have a traveler's check, which is an original form of tokenization, American Express, at least the United States, always said, just give us the number. If it hasn't been used yet, we'll give it back to you. That's just the beginning of that process of letting the network create trust. And all we're doing today is digitizing that at some level. It's more complicated than that, but that's the point.
Right. So this is very interesting, because this is what we call the asset-owner relationship. And you don't have that in the physical world with money. You have money in your pocket. It can be Michael money, my money, your money. We don't know. If I have a transaction on the Stellar network or any token, I can prove it's mine. I can prove I had it before because I have an history. So this asset-owner relationship history is extremely important when we speak about security token. This is another thing we did not speak about, but now we are going into the blockchain space and the crypto space to securities token. And there's a lot of things coming. And it's extremely complicated, absolutely not at the technical level. but it's complicated by regulatory framework in different countries and laws that will prevent you to exchange. If, by example, I want to buy a land in Thailand, I cannot because I'm a foreigner. And if I want to create a company in Thailand, I need to have 51% of the company owned by. So let's say that I want to tokenize Sharkaroo tomorrow and say, okay, Sharkaroo is tokenized. I will sell Sharkaroo token as equity, as share of the company to everyone I want. I will have a big problem because I need to comply to the Thai regulatory framework because Sharkaroo is in Thailand. And if someone in the US wants to buy a Sharkaroo token, I cannot let him do if I... There's a lot of things that we need to deal with, and they are complicated by all the regulatory laws that are different in many countries. The tech is here, but the challenge will not be technical, to be honest.
Time for a couple more questions before we step out. Yes?
Yes?
Yes, my question is about traceability and trustability. As we know that about food waste and loss prevention and billions of dollars of the food waste, and it's not only about whether it's traceable or not, but it's where should it be. Like we ship the merchandise, let's say to Europe, but it's hit there on Friday evening, and then within 2 days the perishable goods will be spoiled. Then the question is whether how should what would be the best possible tool as our time to manage all of this, say, transaction or logistic, and in the meantime, most affordable for the smallholder farmer or, like the people with less financial support, would the, Stella would be the best possible tool?
So there's different things in your question. The first thing is about traceability and getting the feedback on information. So that means you need to have some milestone in your supply chain, from the producer to the shipping, to the cargo, to the unshipping, to the delivery, and these are milestones. And what IBM is doing with Maersk, probably you heard about this, they are doing a supply chain tracking network, and they use IoT heavily, because with IoT you could have a container. Let's say that you want to be sure that the cold chain has not been broken, because you have some product and you need to be sure that this product has always been transported at the same temperature. So they can put some devices, that's what they do. They put devices inside the container, and this container will guarantee that any change of temperature will be recorded. And they are actually sending that to, it's an hybrid blockchain, because IBM has its own technology that's called Hyperledger Fabric. It's an enterprise blockchain framework. It's completely different than what we've been seeing on this one. But it's tracking with milestone IoT devices, and you need to report the information every time you hit some points. So IOTA has been designed for this. Unfortunately, it's not working for now. And in the case of IBM, yes, that's true. In the case of IBM, they are using their own chain node for that, based on Hyperledger Fabric. But there are some projects on Stellar, actually, that can achieve basically the same thing, because you just need your IoT to send the data to the Stellar network. I would say for this kind of supply chain solution, you need a network that is very fast. So forget proof of work consensus, forget proof of stake, Ethereum, or this, it's not the point. You need a technology that can scale, and you need something that you can really easily integrate into your IT architecture. And that's why we really work with Stellar, because it's a database. I plug it anywhere into our customer IT architecture, and you can do a lot of things directly on the database. You can query, you can report, you don't have to hit the blockchain every time. So you can do a lot of things off-chain, and you can reach the blockchain when you need it. In the case of supply chain, at least it's my point of view, a lot of the operation has to be done off-chain. Otherwise, it's too expensive, too costly, you cannot store the data. But a combination of IoT and a very fast network like Stellar could be a very interesting experimentation, yes. I would not go for IOTA now, because it's way too unstable. But this kind of network can be interesting, yeah.
All right, last question.
Most of your talk has been technical and
about
explaining to people how distributed ledger technology works, and I think you did a great job. Can you talk a little bit, since you're located here in Thailand, your company is here in Thailand, what do you see as the biggest challenges facing distributed ledger technology here, and what's the biggest opportunity?
Very good question. Difficult. Maybe our CFO want to answer. You see how I dropped the question.
Thank you.
I will go back to it after.
Thank you for passing the buck.
Thank you.
I think it's a very interesting question, and I don't think the answer applies only to Thailand. I think, as with all tech, tech is there to support a business idea. Tech is there to support an objective, and it works within a context, and that context is within a country. In Thailand, rules, Richard mentioned a few rules regarding land ownership, company ownership, I think will be the main source of threats or opportunity for the future. So compliance with local laws, compliance with what you're able to do with the technology will be the source of growth. And that applies in the US, that applies here in Thailand, that applies in every country. If you look at specific industries, I think forgetting or putting aside the compliance issue, I think there's a lot of potential with agriculture, especially here in Thailand. I think there's a lot of opportunities around food technology, traceability, improving supply chain. These will be very interesting markets to look at in the future. There's a lot to do with production, factories, and improving both the supply but also the IoT side of things, and understanding and improving the efficiency of production. And as in with all countries, financial services, third-party services, services to people, these will be equally of interest as well. Maybe Richard has some things to add. You see, I'm passing the buck back to you.
As we said, we have a lot of tech coming out. It's the beginning, as always with the tech. Nobody knows where we will be in 5 years. I can just tell you it will be probably nothing that we expected. If you look at internet in 1995, where we are now, it's completely different. So technologically speaking, we have tons of tech, but the biggest problem that we are reaching now is probably regulatory and also people. I mean, people need to get consensus on something. Companies need to get consensus also. And if we speak about smart contracts, everybody, I did not have time to speak about this, but smart contract seems to be able to cure everything in the world. Everything you can think about, a smart contract will fix it. First, for me, smart contracts are not smart at all. They are dumb programs. If you look what a smart contract is doing compared to what we can do with our developer, actually, it's basically nothing. If this, do that. We have software since 30 years that are much more efficient than smart contracts. But everybody is saying that smart contract will reshape the world. Okay, I don't think so. Actually, it's not really proving that it's working. And also, let's say that you want to abstract everything at a tech level with a smart contract. Business world does not work like this. If I work with Michael, my company has a contract with Michael, I mean a written one. I will not put my smart contract on a distributed ledger and wait for the smart contract to decide. So the business world is using different rules than what we are living with in innovation space. Innovation space is thinking without boundaries. We can do everything we want. That does not mean that the business will follow. And basically, if you look actually at the blockchain and distributed ledger technologies, nobody is following. Everybody is experimenting. We are trying things with the banks, with everything, but there's no clear path or a clear technology winner that say, hey, this will take us to the moon or to wherever you want. No, we are really in an experimentation phase now, and a lot of things are coming. It's decade long. I don't think we will see anything until 5 to 10 years, to be honest. It will take time. Look at internet, started in 1995, where we were in 2005, where we are now. It's exactly the same with any kind of tech. It takes time and it changes.
With that nice overhead question to close with, and we'll have time now. Afterwards, we'll have some snacks out front. We can talk one-on-one with Richard.
Thank you very much.
Team as well. Join me in thanking Richard for a very
Thank you. Thanks a lot, guys.